Welcome to Chapter 9. In this chapter, we're going to talk about arithmetic and geometric sequences. The main difference is in one sequence, you add or subtract a value to get from one term to the next. In the other, in a geometric sequence, you multiply by a common ratio to get from one term in a sequence to the next term. So we're going to begin by talking about section 9.1, which involves mathematical patterns. So I have some vocabulary for us if you want to take a minute and just copy down the vocabulary, and then we're going to add to these definitions. So leave a couple lines of space between each of the bullet points. A sequence is an ordered list of numbers. An explicit formula describes the nth term of a sequence using n, and then a recursive formula relates each term to the term before it. So it's a formula that will give you the next term in the sequence based on you knowing the term right before this next term. If you need to pause the video, do that now to finish filling in your definitions. All right, so let's talk about a sequence. A sequence is an ordered list of numbers. Here's an example of a sequence. 1, 4, 7, 10, 13, 16, 19. Can you guess what the next number is going to be? Did you say 22? If you did, you're right. So there's an ordered list of numbers. Our first term would be a sub 1 is 1. I could say that a sub 4 is 10, and then 5, 6, 19 would be a sub 7, 22 would be a sub 8. So a and then the subscript just tells us what number in the list of ordered numbers it is. All right, then let's talk about an explicit formula. So an explicit formula, like I said, describes the nth term of a sequence using n. So as I look at the list of numbers up there, I can write an explicit formula like so. A sub n is equal to 3 times n minus 2. So where did I get that formula? Well, we'll talk about that in the upcoming sections. But for example, a sub 4. I know that a sub 4 is 10, and did that come from 3 times 4 minus 2? Yep, 12 minus 2 is definitely 10. Let's test another one. Is a sub 8 really 3 times 8 minus 2? Yep, 24 minus 2 for sure is 22. Okay, we'll come back to how to come up with these explicit formulas in the upcoming chapters. And then a recursive formula. So a recursive formula, again, relates each term to the term before it. So what I can say is that a sub n is equal to a sub n minus 1, n minus 1 being the term. I'm going to say the previous term. Let me erase this. It's the previous term. And then how do I get to the next term in each of these? In the sequence, each of these is plus 3, plus 3, plus 3. So I would take the term before it, and I'd add 3. So for example, a sub 8 is equal to a sub 7 plus 3. Is that true? Yep, a sub 7 is 19, and 19 plus 3 is indeed 22. So that's how we use a recursive formula. All right, let's do some examples. So for example, let's write a recursive formula to describe the following sequence. And I'm going to give you a sequence. I want to turn this to pink. The sequence is 80, 77, 74, 71, what do you suppose comes next? 68, and so on and so forth. So we need to write a recursive formula. Well, to get from 80 to 77, I have to subtract 3. 77 to 74, subtract 3. 74 to 71, subtract 3. So our recursive formula will be a sub n is equal to a sub n minus 1 minus 3. Again, this is, remember, the previous term. This is your previous term minus 3. And you're always going to use that notation for a recursive formula. A sub n minus 1. A sub n minus 1. Sub means like as a subscript. Okay, so there's our recursive formula for that given sequence. In this next formula. We're going to write an explicit formula, and here's our new sequence. 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, and then you probably get what's happening. Next in line would be 1 over 7, and then 1 over 8. I want to take a minute and talk about this notation that I'm using. After the last term that I gave, I put a comma, and then these 3 dots. These 3 dots following the comma say there's more terms in here following the same pattern. And then I could even like put another comma and then pick it up, like with 1 over 101, 1 over 102, 1 over 103, and then comma, dot, 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 saying it's going to keep going forever and ever towards infinity. Okay, so anyway, back to an explicit formula. Do you see a pattern? Do you see a pattern? I see 1 over 1 plus 1. I see 1 over 2 plus 1. I see 1 over 3 plus 1. I see 1 over 4 plus 1. And then, see, I mean, the pattern kind of continues, right? I shouldn't have put this plus sign here. These should be commas. The plus signs mean something totally different. Well, in terms of, this is in the first spot. This is in the second spot. This is in the third spot. This is in the fourth spot. This is a sub 1. This is a sub 2. This is a sub 3. This is a sub 4. So my explicit formula could be a sub n is equal to 1 over n plus 1. And that's good enough for that. That's an explicit formula. So if I wanted to find the 100th term, the 100th term would be 1 over 100 plus 1, or 1 over 101. All right, last example. Let's take a look at writing a rule to find the 5th, 6th, and 7th terms of the sequence that is defined as a sub n is equal to n plus 1 quantity squared. So I want the 5th term, so a sub 5. I want a sub 6, and then I want a sub 7. Okay, so a sub 5 is going to be 5 plus 1 squared, or 36. A sub 6 will be 6 plus 1 squared, which will give me 49. A sub 7, 7 plus 1 squared is 8 squared, or 64. So there we go. That's how we find the 5th, 6th, and 7th terms. All right, that's all I have for today. Feel free to rewind, rewatch, relearn, and I'll see you tomorrow.